Welcome to the mid-chapter review on exponential and logarithmic functions. In this class with my student Chelsy, we'll go through the basic concepts and see how do we apply them in solving test questions. You can always join my classes by sending an email on the address given here. Hi Chelsy, how are you doing?
Sir, I'm good. How are you?
Very good, very good. So, how was your winter break?
Very good. It was nice to have 2 weeks off.
Now back to school, right?
Yeah.
Today, what do you want to learn?
Today I wanted to do chapter 8, mid-chapter review on logarithms.
Very good. Share your exercise. We'll go through it.
Okay.
You can share it now. Yes. So you have understood all the concepts about logarithms, correct?
Yeah, I went through
Very good. So we can easily go through this mid review. I'll like you to answer the questions as fast as possible, right? Let's say we have 20 minutes to go. Okay.
Okay.
8.1, express in logarithmic form. Y equals to 5 to the power of x. How will you express? Tell me.
Just log 5 to the power of y.
So base is 5, right? So base will remain as 5, correct? So you could do like this. You can take base as 5. So you can write log to the base 5 of y equals to log to the base 5 of 5 to the power of x. You see that? And you know the right hand side is only x. So we get log to the base 5 of y equals to x. You see that?
Yeah.
So we have all of a sudden written this exponential equation in logarithmic form, right? So base is 5. Remember that. Base remains same. And we have isolated x. In this process, we have isolated x, right?
Yeah.
By using the inverse function logarithms, right? Y log is inverse. So log to the base 5 of y is x. Clear?
Yeah.
Let's take the second question now, which is express in exponential form. So if I have to write it in exponential form, let's take this one. How will I write t equals to log to the base of what is it?
Oh, such a small number. Sorry. I think
S.
S.
How will you write this in exponential form?
So s to the power of t equals r.
Yes, correct. S to the power of t equals to r. Perfect. Let's move on to question number 3. Yes. Let's do which part? Let's say fractions. C. Tell me. Read the question, please.
Describe the transformations of the parent function y equals log x that result in f of x.
Correct. So tell me transformations. 1/4 of log of 1/4 of x.
Yeah,
What does
so
it really means? Yeah.
vertical compression of 1/4,
Yes.
and
By
then
a factor of. You should write by a factor of 1/4. Is it okay?
yeah, okay,
And then
horizontal compression
stretch.
by a factor of 4.
Stretch by a factor of 4. Yes. Correct. So that is how you're going to write, and that's clear, right?
Mhm.
So, okay. So let's move on to question number 4, please.
Number 4, given the parent function y equals log base 3 to x, write the equation of the function that results from each set of transformations.
Yeah.
So for A,
Mm-hmm. Vertical stretch by a factor of 4. So I'll write 4 here, right? Followed by a reflection on the x-axis. So that is minus 4. And we are log to the base 3 of x. Is that clear? Yeah. Okay, let's do part C. Vertical compression by a factor of 2/3. So it's 2/3. Followed by a horizontal stretch. So that means log to the base 3. Horizontal stretch by a factor of 2/3. So what will come inside?
1/2.
3/2, right? So you'll flip it.
Huh.
Oh, sorry, 1/2. Yeah, I'm reading this again. Sorry, 1/2, 1/2.
Yeah.
Yeah,
Okay.
you're right. I read that 3/2/3. Okay, great. So let's move on to question number 5, please. Yeah.
Number 5, state the coordinates of the image point of 9 and 2 for each of the transform functions in question 4.
Okay, let's do D and then we'll do it, correct? So
Yeah.
D, let's write down the equation. Vertical stretch by a factor of 3. So 3 log followed by a reflection in the y-axis. So y-axis means minus here. And a horizontal translation of 1 unit to the right? So horizontal translation of 1 unit to the right means that'll go inside, right? So I should write square bracket minus x minus horizontal translation of 1 unit, right? Is that clear? And log to the base, I think it was 3, right?
Yes. Yeah.
Yeah, log 3 is correct. Now, that is what your point is. So what is the image point? So any point xy will now be, image will be at, x value will become, reflection means minus x, and going right means you have to add 1 to it, correct?
Yeah.
The y values get multiplied by 3. Is it okay?
3y. Yeah.
And we have a point which is given to us as 9, 2. So let's do this. Minus 9 plus 1 and 2 times 3. So which will be minus 8 and 6.
Yeah.
That's the answer, correct? Okay, great. Clear, right? Question number 6. Can you please read it?
How does a graph of f of x equals 2 to log to base 2 x plus 2 compare with the graph of g of x equals log to base 2 to x?
Tell me.
Yeah, so there's a vertical stretch by a factor of 2 and for f of x, and there's also a translation
vertical translation.
Yeah, translation 2 units up.
You are right. So that's done. Let's go to question number 7. That's good going. Evaluate. So let's evaluate A. Tell me. Log to the base 3 of 81.
So that'd be
81 can be written as 3 to the power of 4, and so we get 4 as our answer, right?
Yeah, okay.
Log, let's do D now. Log to the base of 2 by 3. We have log to the base of 2 by 3, and the term here is 27 by 8. So can you write 27 by 8 in terms of 2 by 3? Three by 2 cube, right? 3 cube is 27. 8, 2 cube is 8. So which is same as log to the base 2 by 3 of 2 by 3 of minus 3. And so this is equals to minus 3.
Why is it minus, sir?
Because the exponent, we flipped it. We want 2 by 3.
Yeah.
Base. And it's 3 by 2. So we have to flip it. So we had minus in the exponent. Clear?
Okay. Yeah.
Very good. Let's move on to question number 8.
Evaluate to 3 decimal places.
Well, that you can do with calculator. Next question, base 10. Yeah, 9.
Evaluate the value of each expression to 3 decimal places.
How will you do this? Log to the base 2 of 21. Your calculator has base of 10, correct? So how will you do this? Tell me. You will change the base to 10, correct? So log to the base 10 of 21 divide by log to the base 10 of 2. Then calculate using calculator. Tell me the answer. Change your base formula.
So it's just log 21 divided by log 2.
Correct.
Then you get 4.39.
Okay. Let's move on to the next question. That is
Number,
similar. 8.4. Let's go to lesson 8.4 now.
okay.
Yes.
Express as a single logarithm.
Tell me the first one. Log 7 plus log 4 is what? Multiply them. Product rule, correct? So when you add them, you get multiplied. Log 28 is your single logarithm. Do this. General D. Log of to the base P of Q. Q plus Q times Q, Q square, right? You'll multiply Q and Q, correct?
Yeah.
That's clear. Go to the next question, please.
Well,
Evaluate. Yeah.
evaluate.
So 33 divided by 3, which is 11, right?
Mhm.
So log 11 of 11 is 1.
Could we do number E, sir?
E, yes. So we have log to the base 4. 16 can be written as 4 square, right?
Yes.
And then cube root. So that is 4 to the power of 2 over 3, right? And
Yeah.
therefore the answer is 2 over 3. You
Okay.
see how easy it is?
Mhm.
Correct. Let's move on to question number 12.
Describe how the graph of f of x equals log base x to the 3 is related to the graph of g of x equals log x.
Tell me,
So the only difference is just to the power of 3.
which is equal to 3 times log of x, correct? So it is a vertical stretch by a factor of 3, right?
Mm.
You should be solving like this a test paper, okay?
Okay.
Factor of 3. Done. Next question, please.
13. Use a calculator to evaluate each expression to 2
Easy,
decimals.
right? You can calculate. Okay, next. Are we done?
I think that's it, sir. Yeah.
What? Oh, man. So it didn't even take 10 minutes. Okay, next chapter. Solving exponential equations. Correct. Let's go through this.
Yeah.
Mm. Oh, we did these kinds of questions earlier, right? But
Oh,
this
yeah.
must be slightly more difficult. Okay. So solving exponential functions, that's not a problem at all. Let's go to the exercise. Okay. Let's begin. Let's continue the rhythm. The very first one, 5 to the power of x is 625. Very easy. You can write 625 as power of 5, right?
Mhm.
625 is 25 square, you know. And 25 is 5 square. So means 5 to the power of 4. And therefore, x is equal to 4, correct? So make the same base. So the idea in question number 1 is to make the same base, correct?
Yeah.
Can you do f? 4 to the power of 2x equals to 1 over 16. 16 can be written as 1 over 4 square, which is 4 to the power of minus 2. So that means 2x is equals to minus 2. X is equals to minus 2 over 2, which is minus 1.
Mhm.
Clear. Next question, please. Question number 2, rounding. Okay, we'll round it. So 2 to the power of x is 17, right? So how will you solve for x? Tell me.
So for this, we can't make the same base, right?
Take log both sides. So basically, in this case question, take log both sides. So we have, when you take log on this side, it becomes like I'm writing, but you could straight away write also, right? It goes to log of 17, right? Base 10 we have taken. So this is x log 2 equals to log of 17, which you can calculate. So x is equals to log of 17 divided by log of 2, correct?
Yeah.
Done. Next question, please.
Number 3, solve by rewriting in exponential form.
Okay, so let's do this one. So x equals to, let me write bigger, x equals to log to the base 3 of 1 over square root 3. So this becomes 3 to the power of x equals to 1 over square root 3. So 3 to the power of x is 1 over 3 to the power of half, which is 3 to the power of minus half. So x is equals to minus half, correct?
Mhm.
Done. Next question, please.
For the
Yeah, read the question.
The formula to calculate the mass m of t remaining from an original sample of radioactive material with mass p is determined using the formula m of t equals p of 1/2 to the power of t over h, where t is time and h is half-life of the substance. The half-life of a radioactive substance is 8 hours. How long will it take for a 300-gram sample to decay to each mass?
Okay. So we know the initial value, which is 300 grams to decay in, and half-life of 8 hours to decay to 200. So we'll write the equation, plug in 2 for the final value, right? So, and then we'll solve it, right? So we have 200, oops, where did it go? So 200 equals to the equation where p value is 300 and half-life time t, we want to figure out how much it is divided by 8, which is the half-life, correct?
Yeah.
So you can first divide by 300. So you get 200 over 300 equals to half of to the power of t over 8, correct? So
Yeah.
that is 2 over 3, right? So we take log on both the sides. We say log of 2 over 3 equals to, when you take log on this side, you get t over 8 log of 2, correct? Log of half, correct?
Yeah.
Now, we can rearrange. So we get log of 2 over 3 divided by log of half. We multiply by 8 to get the value of t. You can use the calculator, find the answer. Likewise, we can do others. Use brackets.
Uh, 4.679.
Okay. Write that as your answer. Is it okay? Great. Next question, please.
Number 5, solve.
Okay, let's take this one. So let me rewrite. We have 9 to the power of 2x plus 1. Okay, let's clear it. 9 to the power of 2x plus 1 equals to 81 times 27 to the power of x. So in this case, we can write all these in terms of 3 to the power. Is it okay? So we'll have the same base.
Yeah.
So I could write 9 as 3 squared, right? So 9 I am writing as 3 squared. And so times 2x plus 1. So that is the first exponent. 81 is 3 to the power of 4, right?
Yeah.
And 27 is 3 to the power of 3, and that is to the power of x, correct? So now we can write 3 to the power of, open the bracket, we have what? 4x plus 2 on the left side. This side, we'll add them up, right? 3 to the power of 4 plus 3x. Is that clear?
Yeah.
Equate the exponents. 4x plus 2 equals to 4 plus 3x. Solve for x. 4x minus 3x equals to 4 minus 2. X is equals to 2. Done. You can substitute this value and check your answer. Is that okay?
Yeah.
It's a good idea. That's clear. Go to the next question, please.
Number 6.
Yeah.
A, if $500 is deposited onto an account that pays 8% per a compounded annually, or for compounded annually, how long will it take for the deposit to double?
So double time, right? So if $500 is deposited, so we want the final amount. We know principal amount is 500, correct? And it deposited into an account that pays 8%, so it increases by 8%. So 1 plus 0.08. 8% is 8 over 100. Is it okay?
Yeah.
Is compounded annually. How long will it take for deposit to double? So this is to the power of time t. Is it okay? So every year it gets compounded. So to double means A becomes 1000, right? You can calculate. Okay, so it becomes 1000 divided by 500, which is 2, which is of course doubling, right? So you have 1.08 to the power of t. So we can now rearrange. We can say log of 2, this is 2, right? So log of 2 equals to t times log of 1.08. So t equals to log 2 divided by log of 1.08. Tell me what is the answer?
9.006.
So in 9 years, it is almost going to double, correct? So let's clear this and next question, please.
Should we do 6b or move on to 7?
We'll go to 7. Those are similar kind.
Number
Let me tell you one thing. 6, let's see D, okay?
Okay.
If you invested $500 in an account that pays 12% per annum compounded weekly, do you see weekly? So now there are 52 weeks. So therefore, the interest rate will be 12% divided by 52. Is it okay?
Yeah.
So the amount here will be A equals to 500 into 1 plus. The interest rate of 12% means 12 divided by 100. Let me write like this. Times compounded weekly. So weekly means divide by 1. There are 52 weeks. Is that okay? And the time period, every week it gets compounded. So it becomes 52t here in the exponent. Do you see the change?
Oh, yeah.
Now doubling means this becomes 1000. And now you have 2 equals to calculate this value. Is it okay? And then solve it. Can you do it later?
Yeah.
Good. But that's the formula. Is it okay? Perfect. Question number 7, please.
A bacterial culture doubles every 15 minutes. How long will it take for a culture of 20 bacteria to grow to a population of 163,840?
So doubling time, so amount M is equals to initial value. So let's say M0, initial value, times doubling time is 2, T over doubling time. That's your formula. Is it okay? Now in this particular formula, we are already given the bacteria culture doubles every 15 minutes. So doubling time is 15 minutes. How long will it take for a culture of 20 bacteria? This is 20, right? So we get 20 to T over 15. The values are in minutes, okay? 163,840. You have to calculate this. Simple as that. Divide by 20 first. Equals to 2 to the power of T over 15, correct?
Yeah.
How much do you get? One six three eight four divided by 2, right? 0, 0 cancel. So 8 and then 1. 18 goes 9 times and 2 times. So 8192 equals to 2 to the power of T over 25. Now take log both sides. So we get log of 8192 equals to T over 15 log of 2. So T is equals to log of 8192 divided by log of 2 times 15. That is your answer. Done. So the whole exercise is over. Clear, Chelsea?
Yeah.
We can end our class here today now. right? I think you've understood each and everything.
Mhm.
So we can end the class here. So, okay. Can you summarize your learnings today?
Yeah, today we went over each chapter in the first half of logarithms. So we focused mainly on word problems, how to find the equation, doing transformations of logarithms. We did some half-life problems. Yeah, that's what we did.
Good. Okay, then. All the best, and we'll continue from here in the next class.
Okay, thank you, sir.
Thank you. Have
Bye.
a great day.